Welcome to our webinar on the value of orbital welding and its application in the semiconductor industry. Hope it's going to be an interesting topic for you. The goal is for us and our partners OWETEC Services to deliver more knowledge and educate you about the value of orbital welding. So please stick around. We're pretty active on social medias, both OWETEC Services and the SFE group. So you will see some posts in the next few days mentioning the next webinars series. And yeah, stay tuned on social media. You'll see that we'll have more webinars coming with live demonstration. So now, Ziad and Nick, why don't you start introducing yourself, and then I'll introduce myself.
Absolutely. Hello, everybody. Thank you for taking the time out of your day to be with us today for about 45 minutes to an hour. We're happy to be here, and we're happy to share with you the knowledge around semiconductor. My name is Ziad Bedran. I'm an engineer by trade. A couple years ago, we'll give a little bit of introduction about OTEC, but a couple years ago, Nick and I found OTEC Services, and we've been since then very busy supporting the welding industry in consulting and training and so on. So with that, I'm gonna give the mic to Nick. He's the brains behind OTEC Services. So he definitely you can learn from him more than you can learn from me, that's for sure.
Thanks, Ziad, I appreciate it. So my name is McMillen. I'm one of the owners here at OTEC Services. As Ziad said, I handle the day-to-day for the more technical side of the house. A little bit about myself. I've been in the welding background or welding field now for almost the better part of 20 years. I'm a CWI and a CWE. I'm also an ASNT level 3 in VT, PT, and UT. So my background ranges from everything to shipbuilding, to the nuclear industry, to semiconductor, biopharmaceutical, and many other different applications. So very excited today to speak to everybody about what are some of the things we're looking at when we're doing orbital welding, how does it affect what we're doing, and how does it play such a tremendous role in the semiconductor applications and semiconductor companies and organizations that are coming back here to the US. As we know, it's becoming a very positive growth market. So orbital welding plays a huge role in that. So really excited to talk to you guys about the do's and the don'ts and what to be aware of.
Thank you, guys. So yeah, you guys, this is a team. This is OWETEC Services. This is a team that's going to do the presentation. Of course, we have a partnership with also the SFE group in the United States. Also, I want to say that we are aware this has been shared with people all around the world. So just so you know, our team is in the United States, but for the SFE group, for example, we have facilities all around the world. So what we say today also applies to our team in other countries. Like, we're here to support you. If you have any question, we would love to help you. One thing I wanted to introduce myself as well. So I'm Benjamin Chevalier, the general manager for the Advanced Welding Division at the SFE Group located in Houston, Texas. I will share my email address in the Q&A section. If you guys have any questions, anything, feel free to reach out to me. I'm really happy to help and try to always be available. So just a quick thing about the SFE group, I wanted to share with you, because a picture sometimes is worth 1,000 words, like they say, right? So the SFE group stands for Specialized Fabrication Equipment Group. We offer several brands, all related to portable machining and pipe fabrication process. Our last acquisition, the company Climax, which makes portable machining solutions, we're headquartered in Newberg, Oregon. They basically you bring the machining solution on the job site instead of sending the part to be machined at the shop. But there are other brands in the SFE group, such as B&B Pipe Tools, that makes pipe jacks, stands, and material handling equipment. Matthew Diamond flame cutting and beveling machines. Also Fitter Pro, which is a brand of Matthew Diamond that makes pipe fitting accessories. PPM makes pipe purging equipment. Sorry, I'm going to scroll down as I go, because otherwise you won't see. But you can go on a website and check all the brands. Then we have TAG and HNS at both brands that makes cold pipe cutting and beveling machines. And we have Axair and Magnatech, which both make orbital welding equipment. Axair is a really good brand for thin pipe and autogenous orbital TIG welding. It also offers a great range of orbital cutting, tube facing tools, and pipe beveling equipment. And Magnatech is really good on orbital pipe welding equipment, and offers solutions to weld any pipe from one inch to unlimited range, with both MIG welding, TIG welding, flux core welding processes. So yeah, that's about it. Just again, the topics today is on semiconductor, more particularly, but because of what's going on in the world with the semiconductor world, it's really a topic that's really important nowadays. And in the welding industry, there's a lot of opportunities. So that's why, but also orbital welding could be used for any other, a lot of other applications at least. So just keep that in mind. We definitely aware of that. So I'm gonna leave the floor to the expert team, and thank you again for participating. Again, this recording will be available at the end of the webinar. Please leave your email address if you want to have access to the recording of the webinar.
Thanks, Ben. Appreciate it.
That's the introduction slide. So yeah. Ben went over all of that. So we introduced ourselves. So again, welcome. Thank you for taking the time out of your day. I know in some areas it's lunchtime, in some areas it's still, it's afternoon, some are like, late afternoon in Europe and all that. But thanks again for attending and being here with us. As Ben mentioned, this is a one-way broadcasting. This is a Teams live event. So, your mics and cameras are off. You can put your questions in the Q&A. We have Adrian. He's kind of overseeing the chat. If you have any questions, he's going to be stopping us along the way, and hopefully we'll answer all the questions for you. We're going to be available right after that as well. So we're not just here for an hour. You can find us online. You can, send us emails and so on and so forth. So with that, this is the agenda for today, introducing OTEC a little bit. This is a semiconductor webinar. So we'll talk about an intro to semiconductor. We're going to go over a little bit of the growth of the semiconductor market in the US specifically, and a little bit about worldwide. How does orbital welding, mesh with the semiconductor industry? We'll go over a little bit on about the product that you spec into a semiconductor application, and then Nick is going to be talking about the codes and standards, and we go over the OTEC offerings that we offer, like from training to consulting, and we'll share our contact information as well. All right, so OTEC Services, as I mentioned earlier, Nick and I, back in 2022, we kind of identified a need and a gap in the industry, in the welding industry in general, and that was around the education and the consulting, and when it comes to welding. So Nick has been in the industry for about 20 years. All along, he's always seen some gaps and need for education. For welders in general, and specifically when you talk about orbital welding, there is minimal to no education at all out there, for any industry, not just the semiconductor, to educate the welders. So Nick and I kind of, talked about it, and then we decided to branch out from the corporations that we're working with into opening our own, firm, I guess, if you want to call it, and we named it OTEC Services. So again, the idea behind it and what drove it is, how can we support the industry? How can we help the welding industry to get better? We work with all the community colleges around the area here and around the country. We work with technical high schools to help them develop and revamp their welding programs. So we're involved in a lot of different areas, as well as corporations like Axair, for sure. We work with them on educating their customers, and in some cases, working with their salespeople to help them, get better at selling the product as well. So we're involved in a lot of different areas, when it comes to welding.
Yeah, if I can, Ziad, really quick, address here, because I think what's important is, as a manufacturer, we are really liable, really responsible for equipment, for the quality of our products. Then we like to team around with partner distributors or a company like you guys who also have a different background, right? Who bring a lot of value as far as the application is concerned. So we like to team around with other experts that we may not sometimes have, or we may need more resource, because training is really important. So so yeah, that's why also we have this going on today.
Absolutely. Thanks, Ben. Absolutely.
No problem.
So what is semiconductor? So we'll get right into, again, what this webinar is for today is understanding a little bit about the semiconductor industry, but also understanding where orbital welding really plays a role and why it's so important to understand what you're working with, or make sure that the quality and the precision and the precise, accurate quality is there for these very expensive microchips that go into your everyday things like cell phones, computers. It can go into jet fighters. I mean, the applications for semiconductor are huge and broad. So what is semiconductor? The foundation of modern electronics. It's also a doping process and its ability to control the flow of electricity and current. It revolutionized, sorry about that, guys. It revolutionized and enabled the development of advanced technologies. So with that being said, there's a lot of growth and a lot of rapid expansion to get these fabs or these industries built. As we know, we have companies like Intel and Samsung and Global Foundries and Micron that are all building and coming back here, Taiwan Semiconductor, that are all coming back here to the States and building these fabs that are used for our everyday life, not only in national security and defense, but our normal everyday life, just make our computers and our cars and our cell phones function. So what does it mean to you? Well, technological semiconductor fabs produce an essential components that power a wide array of devices such as computers, mobile phones, and more. The ICs are the fundamental to most modern technology and industry, including telecommunication, automotive, healthcare, defense, and so on. The economical impact. The semiconductor industry is a major contributor to the global economy. Fabs represent large capital investments, often billions of dollars, and generate many jobs, as we know. Just in the orbital welding and fabrication and production or building of that fab, which is done by a lot of UA workers, which we are very proud to have here in the States to do that for us. There's a lot of training and workforce and a lot of bodies that have to be involved just to get these running and make sure that they're sustainable, they're safe, and they're operating correctly at a high functioning level. So national security. Many nations see semiconductor manufacturing capacity as an issue of national security, enabling their own electronic systems to produce domestically and reducing reliance to foreign sources. So pretty much meaning, how do we have the latest and greatest technology? How are we staying one step ahead of what everybody else is doing, what the other countries are doing? And maybe not even just staying a step ahead, but staying current with them so that all of our technology is where it needs to be, not only on a national security level, but just for an everyday life. So innovation. Semiconductor fabs are also driven and innovative. Continuous advancements in semiconductor technology lead to faster, more efficient, compact electronics, supporting the growth of other industries and technological fields. Meaning, when we talk about like tool installs and the meat and potatoes of where the semiconductor magic kind of happens, you have very small, intricate components that have to come together. Fittings that we're going to talk about in later slides, like VCRs and microfits and DP valves, and they're tightly compact and put together. And there's welding that's involved in this. So a lot of different challenges on the quality and the consistency and just getting the application to actually work or do what you want it to, because everything about semiconductor is smaller and more of it, right? How much can I fit on this little chip before I run out of room? So Just things to keep in mind. And what is a fab? Manufacturing facilities where devices like integrated circuits, ICs, are produced. They're the heart of the whole system. So, and we'll talk about this more as we go into the slides.
All right.
Yeah, quick data that I pulled from the internet, nothing new, but just to give a current state on the semiconductor market in the world, is today I think it's $625 billion, and they project it to become $1,307 billion by 2032. So in not even 10 years from now, it's gonna double by size.
Oh yeah, I believe it, Ben. I believe it.
The internet says it, so
it must be true, right? So,
be true, right?
Regardless of the number, we know it's the growth around semiconductor market is tremendous right now in the States.
Absolutely. And this is a slide that's gonna kind of back up a little bit what Ben and Nick talked about in the previous slide. With having those major corporations like Taiwan Semiconductor, Intel, Samsung, I mean, moving to the States or being abroad, I mean, these guys are growing in a fast pace, and it gets to a point where growing that fast, you need the workforce to support it, right? So obviously, if you're growing that fast, you're gonna need the expertise. It's based on what Nick mentioned earlier. The fact that you are dealing with critical applications such as the semiconductor and everything that get into it, you're gonna need not just experts or welders. You need expert welders. You need welders that are educated properly in order for them to know what to do and how to handle critical applications like that, right? So that is definitely a lack of workforce in the States and worldwide. Per the American Weld Society, they state that is a shortage of 360,000 welders that are needed by 2027. That means they need from 2023 all the way to 2027, they need to fill in 90,000 jobs, welders, every year in order for them to be able to support that growth that's happening in the semiconductor. So, how are we going to be doing that? Who's supporting all of this? I know all these corporations are doing, they have some internal programs to try to support that, but this is where OTEC comes in, right? So this is where we come in and where we can support these major corporations, the contractors that are working for those corporations to build the fabs or to support that day-to-day. This is where we come in. We come in and we educate, we support, those companies and obviously the education and the consulting side of it. And as Nick mentioned earlier, we work closely with the UA across the country. We help them with, if that is a need for a load of UA workers to go at a site to get a job done, and they need a company to come and train them on when it comes to orbital welding, that's what we do as well. Obviously, the importance of the training because of the critical applications.
And we should mention that, the UA has a very good training program, which is fortunate because not a lot of other employees or employers have training programs put in place like that. But even with the mass amount of people that the world needs right now around orbital welding and welding in general, there are those times that there might be additional training needed on different product or different things that are going on with orbital or things they haven't seen. And that's where OTEC helps maybe take them to another level where, a mechanical contractor is looking for their UA members to maybe get some additional training.
Yeah.
But again, the UA also has a wonderful training, but as we know, it's for the UA, and there's plenty of other people that still need to be trained as well. So that's where we come in and help as well. Absolutely.
And again, like the compliance with strict quality and safety regulations for the semiconductor, working in the controlled environments, those are things that are definitely, corporations like TSMC and Intel and Samsung, they are concerned about. They want to make sure that whoever is coming on site, they know what to do. And they don't want, every mistake there, it's not a cheap mistake, as we all know. Those are expensive applications, expensive systems.
It could even be a hazardous mistake.
Oh yeah, it's not just expense, not money, it's a safety as well. People can die if someone makes a mistake, right? So we take safety very seriously, in our training programs that we developed in the past couple of years. as well as the consulting programs that we have. Safety is a big major. It's a major portion of our training as well. So I guess this is where Nick is going to talk about a little bit about the orbital welding.
So,
thanks, guys, for the great pictures, by the way.
So what is orbital welding? So let's start with orbital welding is an autogenous fusion-based welding process that is normally done in a closed head application. It can be in an open head application, but 99% of the time you're going to see it in a closed head application. So when I say the word autogenous, it's a big fancy word. Some folks might not be very familiar with it, or it almost sounds made up. It means without the adaptation of filler material, meaning you're taking two square groove butt joints that have to be not only perfectly prepared, where machining and preparation are very critical to the orbital welding application, but you're using the base material as your filler. So understanding weld shrinkage and axial and angular misalignment and discoloration, which we'll get into more about quality here in a little bit, are super critical things to be aware about around the orbital welding. So orbital welding is a specialized area of welding. As we know, we're talking today about how there's a lack of knowledge around it. So we know it's a specialized application. A lot of folks think, oh, I've been a manual welder for years, and I think I can say I've hung with the best of them. I'm not by far the best, but I think I call myself a pretty good manual welder. And it was such a different world even for myself when I got into the orbital, because it kind of takes the whole operator dexterity skill set of doing it manually or making those adjustments on the fly. You're more of an operator at this point, making sure every variable and every setup and what you're going to do is what you want as soon as you hit that start button. It's almost like being a CNC machinist with welding. So the orbital process is the path the electrode takes around the weld joint. As we know, you have an electrode that creates a plasma. We won't get too crazy into all the definition or terminology, but it's without filler metal. So we're, again, making that plasma that's created through an ionized organized gas column of either argon or argon helium or argon hydrogen to create a plasma that's going to allow us to make a weld, or create fusion, I should say. It's used to meet technical requirements of specific weld assemblies or applications. Some of those applications, as we know, the big one is semiconductor. It's highly used because of the thin wall, small diameter tubing that is involved in semiconductor market. Not only that, the very precision and precise ability of orbital welding, where there are some very fantastic manual welders in the world. But not only does it take, there's a saying at the shipyard that I always used to like to use, that back when I worked at Newport News, and it's when something like, me, the CEO, could be replaced tomorrow, but it takes 10 years to train and build a nuclear components welder, or a nuclear pipe welder, as they would say. And that holds a lot of true statement. The skill set and the dexterity it takes to become a good manual welder takes a long time. And I'm not saying there isn't a lot of training that's required around orbital welding, but it's by far not that much. And with that being said, it's very useful in these markets where we're talking about the precision, high repeatability, high productivity, and quality that's required for these markets. So it's used to meet technical requirements for specific welds, as we covered. The importance of orbital welding: precision, consistency, acceptability, productivity, quality assurance, and safety. All of these are tremendously important. Again, markets not only being semiconductor, but oil and gas, hydrogen, which is becoming really huge in the world, that we do a lot of training around, that we've seen lately. Biopharmaceutical, where we get our medicine, or food, beverage, and dairy, where they make our food. I always tell everybody, a couple of statements I make when I'm teaching a class is, we're not building sprinkler systems, right? We need everything to stay inside. But we also have to worry about things like, entrapment areas, or areas where corrosion or bacteria can set in to these piping systems, and orbital welding really kind of helps counteract that if done properly and performed correctly.
Yep.
So the importance of using orbital weld equipment in semiconductor market. Gas and chemical delivery systems is huge, because the chemicals that are used in semiconductor are not tremendously expensive, depending on what part of the application it's in, usually like in the tool install area or vapor deposition, but they're extremely dangerous. sometimes you'll see in certain parts of the fab, they have what's called coaxial tubing, just for that fact, where they're either pulling a vacuum where there's a tube inside of a tube, or they put a heavy gas on top of the lighter gas, just as a second security to make sure if a leak or something gets out, that it doesn't cause hazard or death to any of the employees or people inside of that fab.
Safety factor.
It's a safety factor, correct. So vacuum chambers, where we're pulling tremendous amounts of vacuum. You know, we'll get into this more about around VCRs, where Ziad will talk about it, but VCRs are welded to certain components in a fabrication. The VCR is rated for, you know, tremendous vacuums, but the welding to the VCR has to also be done correctly, or you're not going to get that vacuum rating that you're looking for. High purity piping. We could talk about this for honestly its own slide, you know, its own presentation, but the whole day. But high purity piping is tremendously important when we talk about surface finishes, entrapment areas, corrosion. All of these are discoloration, which we'll talk about a little bit when we get into quality. But all of these reasons why the semiconductor market uses the best of the best, or the most high purity tubing that's available, because of the gases that are coming through these systems.
Yep.
All play a role on how they perform or react or contribute to the process. Semiconductor tooling and fabrication equipment. Again, as we know, this is very important because everything has to be delivered to that area where that wafer is. That's the critical area where the chip or the semiconductor, the microchip, is being produced or manufactured. And if something is not done right, if something is not ran right, or something is not welded right, not only is it going to cost them millions of dollars, but you'll ruin chips.
Per minute.
Per minute. I mean, probably. I don't know the facts on that, but I'm sure it's minutes that we're losing money.
Absolutely.
So making sure all that is welded and fabricated correctly to the right quality and the right standards are tremendously important.
Hey,
so, yes.
Do you mind if I interrupt?
Yeah, please.
Can we back up a little bit, and could we explain what is an orbital welding machine really quick? Because I feel like a lot of people have misconception or don't even know what process, what is TIG welding, or I mean, I know I want you to explain a little bit the basics here, but I think it's important as well to understand, like, how is a weld head built and what does it do when it welds?
Absolutely. I think this is a great question. So to back up a little bit to Ben's question, I already told you that orbital welding is an autogenous fusion-based process, meaning without the application of filler metal. And I mentioned something, and as you can see in the slides here, where we have the axis around that too, it's an enclosed head process, meaning if you're familiar with gas tungsten arc welding, or TIG as its slang term, you know that you have what's called a non-consumable electrode made of tungsten, usually alloyed with like cerium or zirconium or lanthanum, depending on the process or what you're trying to achieve. And that tungsten electrode is using an inert gas sometimes, or it can be an active gas like hydrogen. And it's using these gases, or these mixture of gases, to create what's called an organized column of gas, or an ionization process that allows fusion to occur or create a plasma. That plasma then heats the material to create what's called a weld puddle, and it uses those two base materials, so the two tubes together, in a perfect square groove butt joint. So meaning no chamfer, no preparation, just butt to butt. And it allows for that fusion process on that seam to take place, where it seals it and creates a weld. It almost looks exactly like a TIG weld without the filler metal. Mm-hmm. Now, when we get into more of the process, we dive deeper into it. We know purging and discoloration, how to prevent those, why it's so important. And then the other thing about the actual machine itself, it's a programmable, synchronized, direct current electronegative pulse machine. So pretty much meaning, to sum it up,
the power supply, right?
The power supply,
talking about
yeah.
The power supply now.
Yeah.
Okay.
The power supply allows you to develop a weld schedule based on a few parameters: high amps, low amps, travel speed, weld time, and a couple others, just as a high-level explanation of what these variables are. It also talks about things like pulsing rate and pulse time. And pulsing, again, to sum up, is just a a term used where we have a high amount of amps or primary amps and a low amps or background amps that we're pulsing between. And what allows us to do this is it allows us to control that weld puddle in a much more precise, better way than doing it manually. Now we can pulse weld manually as well, but you're not going to be able to capture or have the precision you do around orbital welding with tube and pipe as you would manually.
It's more controlled.
It's more controlled, exactly. And there are other things that go into play too. You have a rotor that spins around that's housing this electrode. And you have to calculate sometimes your rotor speeds and your travel speeds, as you would know that would equate to.
And
so
all of that is incorporated in the weld schedule development, right?
Correct. And the beautiful thing about these machines is they do come with ready to go weld schedules, but no machine is going to give you the perfect weld schedule on every application you're doing in the world.
Yep.
And that's why having the knowledge and the training around this is also very important. Now, there are machines out there like Axair that do a wonderful job, hands down, no doubt. But again, it's always application based on what you're trying to achieve. Some things are really out of the wall, off the wall, not readily doable things or things that people are trying. But orbital welding, what's great about it, makes the unachievable achievable, in my opinion.
Yep.
Yeah, what I wanted to state is I feel like there is some misconception sometimes that people think the orbital welder can replace a welder. Actually, it doesn't, because you have to train somebody to recognize what a high quality weld is going to be and what is the expectation from the code, right, that you're following. And I'm sure you'll come after on that, but also you have to worry about other things like purging, your parameters. So it's great to help you to set up a good schedule, a good weld schedule that you can duplicate and repeat. But let's say you change a material, for example, you go from stainless 316 to a 304, just a different heat of stainless steel. You may have to reprogram your machine with a different schedule because you may have a different reaction of the metal or a different weld quality. So all that is not everybody can be a good orbital welder, if I can say. It's all about experience, training, and also knowing how to use the equipment, and having experience, and also respecting the quality control and following the codes. So there's a lot of quality control involved, and it's not anyone who can be an orbital welder.
And
I agree with this statement tremendously. One of the things I always say in the class is the moment this machine can do the work for me, we'll all be out of a job, meaning they can't do the work for you. Just like I talked about with the manual welding, it takes years and years of training. The orbital, but in its own way, right? It's got its own challenges and things to recognize. Like Ben touched base on it perfectly. There are different things that we have to become trained on. But what is beautiful about the orbital welding, once we are trained and recognize those challenges and know how to overcome them or how to use the machine, that's the real segment. How to use the equipment or the machine to produce what I want to do or make weld schedules the way I want them to operate or function. You can make this equipment do a lot of amazing things.
Absolutely. Yeah, I feel like it's more knowing how to have your SOP, in place for each company that will really make you successful. And sometimes it depends on the standard, the requirements from the job, but could be more or less complicated. Sometimes it's pretty easy to get up to speed, depending on the expectations of quality from your job. But it's really a repetitive job. It does things like, for example, for small diameter tubing, let's say in the semiconductor, it's all like 1/4 inch, 1/2 inch, 1 inch. I mean, they do bigger things, but most of it is like 1 inch and down, right? And it's really hard to get a repeatability on the small diameter tube because you have to control the heat input all around the tube and the pressure inside with the purging. And those things can be more or less automated it could be fully automated with the good settings on an orbital welding machines.
Answer to that question, great question, by the way. And these are the things that we cover in our training and that we're doing constantly when we're doing the hands-on. So when we talk about purging, the purging most definitely has to be going on the ID or inside diameter of the tubing. Not only for, I make a statement in class all the time, flow equals color, meaning discoloration, but pressure equals profile. And we teach people how to use magnehelic gauges, inches of water, or purge kits, or millibars, you know, whatever you're measuring your pressure in. It can be in different increments, liters a minute. But understanding the pressure will allow you to have the good profile of the weld, because it can create convexity and concavity on the inside or outside of the tubing, or even lead to blowouts. And discoloration, when we talk about stainless steel, a lot of people really don't realize, a lot of welders see these purples and these blues, and they're like, oh, that weld looks so good. But what we're doing is we're essentially diminishing the properties of stainless steel material.
Yep.
One of the things you're doing is breaking out the chromium.
Yep.
So,
and specifically the semiconductor, these are the concavity and convexity and discoloration. These are
unacceptable.
These are unacceptable.
Unacceptable.
You throw them away, and you have to start all over.
I mean, they are literally unacceptable.
Yep.
I mean, semiconductor market has one of the most stringent codes and standards to follow around orbital welding.
Yep. And you gotta be precise when you build your you know, scheduled development. That's exactly why, you know, a training is definitely needed when it comes to critical applications like the semiconductor.
We'll talk about what can be done in general. So in semiconductor, first off, the largest diameter you usually see is about 4 or 6 inches when you're talking about inlet lines that are coming from the tubing or water lines. This might be done manually. It can also, I have seen it done orbitally or with open heads, which we won't touch about too much on this. Wall thickness, when we talk about tubing, the thickest wall thickness you usually see is about 65 thousandths, maybe 0.83. But you're usually looking at more like 1/4 inch, 0.35, 1/2 inch, 0.35, maybe even thinner, 0.23. So that's why the orbital welding is so great for these, because imagine trying to weld 23 thousandths wall thickness manually, or 35 thousandths wall thickness manually. So,
and in some cases, the manufacturers like Intel or the contract, they require you to go to orbital because they know manual does not.
It's a have to.
Yeah, it's a have to.
Yeah.
It's not like a choice, right?
Yeah.
I mean, at one point, it will become an obligation. You have to know how to do this. Otherwise, you're not going to be able to cut it here, you know?
And then as far as maximum, I'll speak from experience. I've welded with orbital welding, and this is per ASME. There's only a certain amount of maximum you can go to without adding filler material. But I've done 4-inch Schedule 40 pipe with orbital fusion welding on stainless steel 316L.
Wow. Yeah.
Yeah, then you're gonna play with your, you're gonna do what we call a step mode. So there's mode in the power supply that you can pulse. You can rotate the tungsten on the pulse basically, so you stay longer on your welding joint. So you rotate slower and you create more heat. And also there is gas, right? You can use mix of gas and do this becomes next step over the welding, but it's possible to an extent. Then we're talking about pipe welding, right? And pipe welding, it becomes a bevel. You have to have a different fit up. It's a different configuration. You have to add filler metal. So it's here we're mostly talking about fusion autogenous welding in this for the semiconductor industry, but I guess some of the semiconductor industry may use pipe welding at some point too, right?
They do. So.
All right. Great discussion, guys.
Yes.
Great discussion. All right. So I guess we want to talk a little bit about the components and the product, you know, that goes into a semiconductor application. As an engineer myself, you know, with my background, previous corporation I worked at, I was like a custom solution engineer. So a part of my role was to spec components into a system based on the customer application, right? So they send you, they say, okay, I want that. What can I do? This is my application. Those are my parameters, system parameters, and so on and so forth. When we used to come across a semiconductor application, a lot of things, the level of the quality is always up there, like top-notch quality product that you have to pick when you and spec in when you are building a system for a semiconductor. and I don't want to get into the details, but you've got the VCRs, you've got the microfits, you've got the DP valves, and the tubing itself. When you are speccing the tubing for a semiconductor application,
Yes.
it's got to be to a certain standard, and that standard is not an easy one to meet, and it's obviously an expensive one, right? In order for manufacturers to meet.
And the biggest thing is when we start talking about microfits, VCRs, DP valves, how many folks even know what these mean?
Right.
And why that can be dangerous is they have to be welded and handled and prepped and staged in very strict, precision, precise, planned out ways.
Yeah,
I mean, welding a microfit with a 1/4 inch tangent or tube stub length, the first thing is you have to know, what weld head am I using?
Yeah.
Can it fit in there? Can it meet that application need? Welding a VCR, knowing how to handle it, not touching the face, where that seal is supposed to happen and create that perfect vacuum.
Absolutely.
I mean, you touch the face of a VCR in a semiconductor application, you might as well throw it in the trash.
Yep.
And these things are very expensive, and it can be time consuming to get more fittings too. I mean, it's lead times, the things that we're talking about. So to get into the welding of these different fittings and valves, you have to really understand what you're working with and how to handle it before you even talk about the welding of it, which is another portion of it. And to lead back into our training, we train this here at OTEC. We build assemblies with VCRs and DP valves and microfits and actuators. We do all this based on whatever components you're going to be welding. And even in other markets like aerospace and stuff, these are very, very critical things to work with.
Absolutely. I mean, again, as Nick mentioned, it's definitely the criticality of welding those components is very, very important. As you see, like I have mentioned, a couple of things here is the purity that, like you say, like they talk about high purity of the material, right? And how it is machined to the fine finish, the ID and OD and everywhere, right? So it's gotta be entrapment areas has to be, almost zero. So that's just the fitting itself. And now when you start looking at how can I weld it without ending up with an entrapment area, that's another, critical, that's another level of where Nick expertise comes in and train people on how to meet those requirements to of the semiconductor. The compliance to the industry standard is important. That's what we mentioned earlier. If there is any discoloration, if there's any concavity, convexity when it comes to welding, if it's not meeting the industry standard of the semiconductor, ASME Section 9 usually, right? So
Section 9 would be more about we'll get to that.
Yeah,
so
we have a slide on that. Again, that's one of them, right? One of the standards that they have to meet in order for them to be spec'd in and so on. So, that's the speccing the product. And then the welding portion of it is Nick gonna be talking about that a little bit here on, the high quality of the welding and stuff like that.
Yeah, absolutely. So orbital welding in clean room environments and the cleanliness. This is another thing that we train on. This goes into the handling of the components. So high quality welds. Orbital welding ensures precision and consistency in welds, resulting in high quality and reliable connections. This is crucial in the semiconductor industry, as many standard welds can lead to leaks, contamination, or improper functioning of semiconductor components by maintaining strict cleanliness standards. Orbital welding helps prevent defects and ensures the integrity of the critical system is intact. Clean and contamination-free processes. Orbital welding is an automated process that minimizes exposure to contaminants during welding. It eliminates the need for manual handling of the welding torch, reducing the risk of contamination from human contact or particulates or particulate matter during like the vapor deposition process or that plume that comes off a manual welding process. We get it from Orbital as well, but not nearly as much. This is especially important in clean room environments where even minor impurities can affect the functionality of semiconductor devices. Reduce risk of particle generation. Traditional welding processes often produce slag, spatter, and other smaller particulates that can cause contamination. the surrounding area in orbital welding, these issues are significantly reduced or eliminated when we're talking about orbital welding. This helps maintain a cleaner environment and reduces the chances of particulates causing defects or contamination or sensitive components, such as semiconductor equipment. High purity welds. In semiconductor manufacturing, the materials used are often high pure and sensitive, or high purity. Orbital welding techniques such as tungsten arc welding, GTW, allow for precision control of shielding gases and welding environment. This enables the creation of high purity welds that minimal oxidation or contamination, ensuring the integrity of the components you're welding and that they stay intact. So overall, orbital welding is of the utmost importance in the semiconductor industry, particularly in clean room environments. It helps maintain cleanliness, produce high quality welds, reduce contamination risk, and adhere to straight or stringent standards, of which are all vital for the proper functionality and repeatability of semiconductor devices. When we say different angles, absolutely, they don't have to be straight runs. What matters in orbital welding is the amount of tangent or tube stub length that you have to meet center inside of the weld head when it's colleting. But as long as you have that straight amounts to meet that centering, it can be angled off to the sides. As you see up here on the screen, our fittings, we have different configurations, T's, elbows, crosses. All of this can be orbital welded, to answer your question, yes.
Yeah, but you cannot weld at an angle.
No, you cannot weld at so a miter angle, yep, or a fish mouth, as some folks would call it. This is not something that is possible.
Yep.
Now, maybe laterals, right? If somebody implies if you have a tube and a lateral welding to it, you'll have to have a straight clamping distance, straight run.
Correct.
Right?
There's a minimum straight required.
Yeah, there's a minimal straight requirement.
And just for your information, the axial close head, we have different design, but the close head is 1.5 inches wide, right? It's a pretty narrow close head, and so from each side, from the tungsten to the clamp, you have 3/4 inch. Then you can use offset tungsten electrode, which you can move your tungsten inside the close head, so you can actually play with that accessory as well. We can actually make special collets as well, which if you have different configuration, we can adapt to an extent. But what really matters is the clamping, the straight run that you have available on your configuration, and that's where we may have constraints. But
yes,
but overall, there's a lot of configuration that we can weld with accessories.
I'll make this statement. I've been doing this for quite some time, and I've seen some of the weirdest shapes and designs. And I think I can count on one hand how many times where I couldn't get something with some modification and some, out of the box thinking, get it to make the orbital weld I needed.
Yep.
So.
Yeah, it definitely can meet a lot of application, that's for sure. Yeah.
Yes and no. The answer is yes and no. All of the different orbital welding equipments out there in the world have preset programs based on a couple different factors. Some of them based it on just wall thickness and diameter. Some of them based it on wall thickness, diameter, and material. They'll also be based on the kind of weld head you're using, right? So with that being said, a lot of the programs are fairly close on standard run-of-the-mill stuff you would see. But there have been times where even the standard program, I've had to make adjustments and play with the heat to get exactly what I'm looking for, right? Because it also depends on the code and standard or what that ID bead needs to look like, or the weld profile. So even though it might be a full pen weld, it might not be the kind of full pen weld that I need to achieve based on the code and standard or the SOP I'm working to.
Yep.
What I would say is each machine now more or less have the ability to calculate according to diameter, wall thickness, material. A good starter, good weld, what we call a CAN program. So you enter the diameter, wall thickness, material. it will auto-calculate some parameters. Usually you would run a weld on that. It will give you, depending again, like it depends on the material or the heat of the material. And then you will get a weld. From that weld, you can say, okay, I'm going to go back to my weld schedule, modify it, tweak it, increase my amperage. Maybe I can go a little bit faster. So you can tweak your program. That's what's really important. And I think that's what makes a power supply really good, is if you can make quick adjustments like that easily, and that you can see the impacts right away on your weld quality.
And the other thing I would say about that, Ben, I totally agree. Totally agree, couldn't agree more. But in order to do that, it's about knowing what you're looking at, right? And that's where that training piece comes in. So even with the CAN programs that are, again, I want to make it clear, some of them are very good and very close. But if you need to tweak them, that's great. But if you don't know what to tweak, that's the problem. And that's where that training comes in, understanding what each variable means and how it's going to affect the weld as I'm looking at it during the process.
And I think the question had a little bit of, I think I heard coupon, right? So couponing in, couponing out, right?
Oh, absolutely.
All that is important too. You can try, the existing programs that are, built in, but you got to start with couponing in, right? To see if it's meeting the requirements. And if not, this is where you got to start looking at, you got to know what you're doing. You got to know what you're looking for in order for you to know what to tweak and how to tweak it, if that makes sense. All right, so here we're gonna talk about a little bit of high level because we're kind of like 5 minutes away.
Yeah.
I don't wanna spend too much time here if that's okay with you guys, and maybe we'll leave like another 3 minutes for any more questions.
Yeah.
But this is about industry standards and how this is, is important.
So high level is ASME Section 9 is the procedure qualification and performance qualification of welders. So qualifying the procedure that's going to be in place that you're going to follow, and qualifying the welder's performance to those procedures that you put in place. So the recipe and making sure people can follow that recipe is essentially what we're talking about when we're talking about ASME Section 9.
And every recipe is built for the individual company, right? So it's not for the individual, it's not for OTEC, it's or Axia, right? None of us has anything to do with the recipe.
Correct. And by the way, in our trainings on Friday, our last day of that training, we provide creation of PQRs, WPSs, and WOPQs, which if anybody has any questions about what those mean, feel free to ask in the chat. So we have that Section 9 that we follow that talks about recipes and and performance to the recipe, right? So then we have what's called construction codes and standards. This could be BPE, this could be B31.1, B31.3, which is power piping and process piping. Then we have codes like SEMI. And then in SEMI, we have what's called ILF 172 through 178. These talk about the fabrication and installation and welding and requirements to meet semiconductor builds and fabrications. But what's happened a lot in the market and in a lot of years now is that Intel or Samsung or Taiwan Semiconductor or Micron will have their own SOP or standard that you have to work to, what they're looking for. Now, some of this spaces from the code, but at the end of the day, it's what the employer wants, right? You're building a process or you're following the strict fabrication, construction, and quality to what the employer wants. So that's another thing that we do in OTEC is we stay current with what all these requirements are so that if we get employers or mechanical contractors or companies that we know are strictly doing work for these individuals, we train to that standard or that kind of quality that we know they're going to be looking for. Weld inspection and the importance of the quality of welds. We got structural integrity, reliability, contamination control, safety considerations, compliance with industry standards, and cost effective. Pretty much in a nutshell, inspection is crucial when we're talking about any welding process, but especially the orbital welding process. I always tell my orbital welders when I'm training them, who's the first inspector? Who's the first line of defense? It's you, right? You're your own inspector. You shouldn't just be a welder and move on to the next weld joint. You should be cognitive and you know, constantly checking what your work is and what you're doing. Because if you don't know how to read a weld or understand what discontinuities or defects are, and when to determine you have one and how to get rid of that based on, you know, maybe couponing or different processes, you're dead in the water.
Yeah.
At this point, you're a button pusher. So understanding inspection methods and those different defects and discontinuities, when we talk about convexity, concavity, angular misalignment, axial misalignment, discoloration, all of these crater cracks, pinholes, incomplete fusion. The list can go on and on, obviously, but we need to know what those things are. Like another thing is like meandering when we talk about high and low sulfur bearing materials, which happen in the semiconductor, that actually happens sometimes.
Quite
so
often, yeah.
That's where the inspection is very critical and important, and that's why we spend so much time training it. But what's nice about our training is it's incorporated during the welding.
Yep, during the hands-on.
During the hands-on.
Yep, absolutely.
It can, absolutely. Now, elevation is the only time I've seen this, and it's funny that we bring this up, is I just did a training in Colorado. So we have to, we're
no
talking
oxygen.
yeah, no oxygen in Colorado, right? So around the Denver, Boulder area, I noticed when doing pressure, it's a little different than it, yes, because of, you know,
Yeah.
the oxygen content, the differential pressure and all that stuff, which we won't get too crazy into. But when we're talking about humidity, this is a great one. So just like in manual welding, we used to fight this as manual welders too, when we were at to weld our joints. We wanted to make sure we got the moisture content out of our material by either heating or running the weld torch and doing some practice welds for a while. Same thing with Orbital, what we do is called couponing. So your weld could change from the beginning of the day to the end of the day based if you're in a climate where it starts at 25 degrees and then you're at 80 in the afternoon.
Even though you're in a closed environment, because it's a closed head, it's not an open head.
That's a great question too, Ziad. But the thing is, moisture sits everywhere. So during that time where those dew points are fluctuating, you might have moisture content in your weld head. So you want to weld a coupon to make sure you're almost self-cleaning, right? I don't know if it's the best term for it, but you're getting that moisture content and heating the head up and getting everything to an ambient baseline temperature so that the tubes or components you're welding should be consistent.
Yep.
Mainly in semiconductor industries, it's going to be visual inspection. A lot of people are used to borescoping, but one of the things that we're worried about in semiconductor is internal surface finish, meaning I don't want anything inside my tubing, even the borescope.
Yep.
So that's what we have a method called coupon in and coupon out. Real quick explanation on how they usually test welds. Yes, it is visual inspection, 100% visual inspection, by the way, in certain parts of the semiconductor installation and fabrication. But when, let's say we have a visual inspection that fails, what we would do is we have a coupon in the beginning of the day, the inspector will say, okay, that's good, you can start welding. You made your welds, and your last weld is going to be what's called your coupon out. If my coupon out is bad, the inspector is going to start going to look. If the welds he looks fails visual, they borescope. Fails borescope, they cut it out. And they start cutting until they find 2 in a row that are good. It can be more critical or less critical depending on who you're working for. That's normally what happens.
In the semiconductor, a lot of tubes are really small that even a borescope can't really fit in there, right? So
yes,
would be hard to verify. A lot of welds are not checked, but they rely on a lot of couponing, right?
Correct. A lot of couponing is reliable because, Ben, that's a great statement. You can't borescope all the tubing in the semiconductor industry or fabrication, and you can't UT it if that's what people are thinking on this webinar.
Nope.
UT has not got the ability to go that small to do even ultrasonic tests, which would not really show you anything with the kind of technology we have now, or X-rays. So it really is a lot of heavy visual inspection that's required in couponing.
And it's funny, it's different in biopharm, right? Biopharm, I think they require 20% of welds to be borescoped or something like that.
Correct. Yes, depending on who you're working for or the contractor. Yes, that's about the general rule. To answer that question without seeing what they're trying to do or have the information in front of me is a little tricky and difficult, but I will say this about sulfur. When we're talking about low and high and low sulfur bearing materials, we can get what's called the Mangoni effect. Pretty much, it's an effect where you get high, low sulfur bearing materials when you try to weld them, and you get what's called meandering, where the weld will actually be snaking, or it'll shift to the low sulfur bearing material every time. By the way, gentlemen, please. Ladies and gentlemen, feel free to try it. It's always going to shift to the low bearing sulfur side. So with that happening, you can get a lack of penetration or a lack of fusion of the material. So understanding your ASMT report or your MTR, being able to read your MTR material test report is crucial, making sure that sulfur content from each tube is similar.
Yep.
And controlling the sulfur content, usually in semiconductor, it's between 0.5 to 0.10 per weight of sulfur that's in the material.
All right, this is just a quick high level of the OTEC offerings, training and consulting programs that we build. We have additional ones we didn't put on the slide here, but you can reach out and we can discuss those. Nick is gonna go over high level of each one of those, and then we'll go from there.
So in our orbital welding, we have two different orbital welding classes. We have what's called orbital fusion welding, which is to close heads with this no filler material. And then we have our orbital welding open head. These are both week-long training courses. The open head can be up to 2 weeks if you want more training or if you're very new to it. But our orbital welding is always a week long. And at the end of that week, we provide ASME Section 9 qualification to all of that company and to their employees. If they're students, you're going to get qualified to OTEX procedure. Mm-hmm. So it won't be good for you if you go to an employer, but it'll at least be something to show that, hey, I've taken this test and I know how to meet the standards that are required to Section 9. Our Weld Examiner class is exactly how it sounds. We talk about all the importance of code and standards, Section 9, AWS, B31.1, B31.3, and so on. We have weld samples that you inspect, and we train to build that confidence in weld inspection, because as your job as an inspector, it's not to go find something bad. Everybody thinks their job is, there's something bad in here, I know it's somewhere, I've got to find it. Your job is to make sure that the weld meets the SOP or the code and standard to the best objectionable reasoning that you have. That's pretty much what an inspector is. Mm-hmm. So our manual weld training, this varies. It's very customizable, I would say.
Absolutely.
It's based on what you're trying to achieve. It could be on-site, off-site. It could be consulting. It could be several months long. I mean, our manual weld training offers a wide variety of different packages. And then our consulting is exactly what it sounds like. Consulting is we come out for 2 or 3 days. We usually do that for consulting, or it could be over the phone. We write procedures and SOPs. We write QAEs. We consult and review yours. We develop weld training schedules. We develop weld schedules, not training schedules. Anything you can imagine around welding, we can cover it in consulting.
Absolutely. All right. And I guess we're 10 minutes over. We thought we didn't have enough content for an hour, but it went for an hour and 10 minutes here.
I think you can make it as close as you want, but what really constrained is how can you position the wellhead. If you have anything limiting you to position the wellhead, you may be able to build a fixture to position the wellhead, but as far as how close can you weld to another joint, basically you can even weld on another joint, right, or next to the other joint. So
correct. The answer to that, you answered the question perfectly, Ben. The answer to that would be yes. Depending on if you have an offset electrode, what weld head you're using, it's going to be variable dependent on what you have available to you. But they are all very achievable with some configuration and some knowledge around it. I have created some colleting that that is unique to us here at OTEC for branch connections. So it can be done. I won't say it's not tricky. It takes some doing to get it done, but it can be done is the short answer.
I'm wondering if they're talking about something that will have a profile, like a oval profile, or is that talking about like a round profile, you know? If it's a circular, like really round, we can do it even with a closed head with special fixture again. If it's out of round, if it's become like an oval shape, like what a lateral will be connected to, for example, this is not for the typical closed head. Yeah.
Yeah. They're talking about a miter. This is not possible. The answer would be no to this. They're talking like a saddle, almost like a saddle configuration, or yeah.
That's what I was wondering. Yeah. Okay. But like, for example, like if you have sometimes you have those manifolds, you know, manifold which have extrusion. Like I'm gonna name the brand T-Drill that make those T-Drill extrusion, and those are possible to over weld because we do it. We have customers that use our solutions for those. We're gonna stop here anyway, but because we extended the time. But thank you so much, everybody, for connecting. We will again, there will be other webinars. This is a first one. We will do others, so stay tuned. And yeah, next time we'll see you. We'll be with the machine in our hands, and we're planning to go to OWETEC and meet with Nick and Ziad and demonstrate the equipment there with them in Ohio. So that would be a lot of fun.
Looking forward to it.
Looking forward to this series, Ben. It's gonna be a pretty good one.
All right. Well, we hope everybody liked it and enjoyed it, and we'll feel free to connect with us, and feel free to follow us, check our website, follow us on social media, and I'm sure if there's question, you have now more resource to answer all your doubts and concerns and comments about what you know about orbital welding.
Absolutely.
Thank you, everybody. Thanks, everybody. Have a wonderful week.
See you. Bye-bye. Thank you.
Bye-bye.